Hello, friends. Welcome to this session on batch processing and model designer in QGIS. My name is Prasun Kumar Gupta. I am with the Indian Institute of Remote Sensing, which is a unit of Indian Space Research Organization located here in Dehradun. So today we are going to talk about very advanced features inside this open source GIS software called QGIS. There are two functionalities that we are going to talk about. First is batch processing, and the second is modeler as it is called in QGIS. So, what kind of problems are we going to tackle, or what kind of questions are we going to solve using these two tools? Primarily, whenever you're working with remote sensing, GIS data, geoanalytics, once your workflow is defined, the problem that most users face is I have to implement this workflow on multiple data sets. For example, the problem that we are going to tackle today is, let's say you have a lot of data. You have, let's say, daily temperature data in raster format for whole of India or for whole of the state, or you have multiple vector layers like points of interest, road, railways, uh, village boundaries, canal networks, stream networks, so many different types of vector layers, so many different types of raster layers. And you want to clip all of them for your study area, for your watershed, or for your basin. If you want to do it in the conventional or traditional way, you have to run the same tool many number of times. So we are going to see that how we can implement a tool in what is known as a batch mode. So we can do batch processing. We can clip all the files in a single command. So that is what batch processing helps us to do. Implement individual tools on multiple files. On the other hand, the modeler in QGIS helps us make a workflow. A workflow could be, let's say you have to uh, delineate the watershed boundary. So you get a digital elevation model. You first do what is known as fill uh, the sinks. That is, you get a depression-less DEM. Then you follow 2 3 steps like calculating the flow direction, calculating the flow accumulation, and then you need to put a threshold to find the streams, and then you then go on to vectorize the uh, raster streams and so on. So there's a series of steps. You could do it one by one, but what if I could model it, or you could make a sequence of steps like a flow chart in QGIS, and then only input is dem, and you directly get the vectorized stream as output. And then let's say if there is some calibration parameters in between, let's say you want to calibrate the flow accumulation threshold. You want to implement different threshold boundaries and see how it affects the final output. You can do all that repetitive running of the model using modeler. So these are two different tools that we are going to see today. Uh, so let's start with the batch processing mode. You need to open QGIS. So we have QGIS open in front of us, and we will be using certain data. So there are two zip files. One is the data for the batch processing exercise, and there's one zip folder for the modeler exercise. So let us first unzip the batch processing data. So right click, use some Windows software to extract the data here. You will see two files. One is called batch processing, a QGIS project, and then you will see also a geo package file which has several layers inside it. So let us open this batch processing project. You could simply click on the file, drag it and drop it in QGIS, or you could go to project, open. So I have kept my things on desktop, and I could open it from here, from project open in QGIS. Okay, so let me click on open, and what you should see is uh, several layers getting added, uh, mostly like the shape of India. Um, okay, let me just go through each of the layers one by one. So I see some points, like I think they are, uh, let us look at the attribute table. There are 211 points, and they are, I think, what looks like is state capitals or major cities. And then I have the major rivers in India. Then I have the road network, probably the national highways. Then I have some water bodies, lakes, named as a lakes layer. And then there are certain urban areas. Uh, so these are all for India. Now, let's say I'm trying to do a study for a specific state, or let's say Maharashtra or Karnataka, or for a sub basin, or sorry, a basin. So if I have that polygon boundary, how do I clip the rest of the layers, one, two, three, four, 5 layers at a single go? So one thing, the conventional method is that you go to vector, geoprocessing, and there is a function called clip. This clip will take one layer at a time. So let's say the first one, places. I could go to places, and I want to clip it using my state boundary, and then I create a new file and then click on run. So I have to repeat this process 5 times. Instead, I could find the same tool in my processing toolbox and run it as a batch process. So let us have a look at this processing toolbox. Just in case you're not able to view the processing toolbox, uh, there should be a menu option called processing here. Just click on that and then click on the first option which says toolbox. Once you see this toolbox here, just search for clip, and you should see several tools pop up. We will take this option clip inside this subgroup called vector overlay. Okay, so you have to right click on this clip. So now you can see this function clip appearing in the processing toolbox. Right click on it, and then the second option is execute as batch process. So once you click on that, pop-up should come up. Let me just make it bigger for our convenience. Uh, yeah. So there are two things that you need to give. One is the input layer and one is the overlay layer. So input layer is the layer that you want to clip. Okay. So there, let's look at these uh, buttons here. You could add multiple rows here manually and then select the files. You could delete certain rows. Let me delete this already pre-populated row. Let me remove this for now, or maybe I cannot remove it. Uh, it should have a single row. You could save the model, open the model again, and so on. So first thing I want to highlight is this option here which says autofill. Under input layer, the option is autofill. Just click on that. There will be a drop down, and here you have to uh, select this option, select from open layers. That means the layers that are already opened here, we will select from that. So we'll click on this last option, select from open layers. It will show you all these areas. So urban areas is already populated here. So we'll take the rest of them like lakes, roads, rivers, and places. lakes, roads, rivers, and places. Okay, and then we'll click on OK. So now you should see uh, a total of 5 rows with urban areas, lakes, places, rivers, and roads popped up. Okay, so you're seeing it can autofill all the open layers, or you could autofill from files in a directory. You could add all the files from a directory. You can select certain files, or you could filter the files based on a pattern. Let's say you have a folder filled of precipitation, temperature, discharge, several files, but they all have the same name. Like precipitation file starts with precipitation, or max temp, or min temp, and so on. So based on a certain pattern, you could also filter the files to be selected. The next is the overlay layer. As you saw, overlay is the layer that we want to clip with. So what do we want to do here is we want to clip all these layers for this state boundary Karnataka. So within this Karnataka, I want all the urban areas, all the water bodies, uh, the roads, the rivers, and the important places. So to do that, we go to clip, execute as a batch, autofill from open layers, select the layers that I want to clip. Uh, okay, sorry. The places layer is now auto-populated. I will just add urban areas. So now I have lakes, places, rivers, roads, and urban areas. The overlay layer here is the layer that we want to clip it from. Okay, so we are going to clip it using the state boundary. So what I'm going to do, I'm going to say, first I'm going to fill the one first for the first row. I am going to fill it with state boundary, and then what I'm going to say is autofill fill down. So the same value is going to be filled down, or it will ask how do you want to. In some cases it will also ask whether you want to increment or do something with the filling also. So I have my input layers, I have my overlay layer. Now I want to save the output file. So what I'm going to do is for the first row I am going to say that this the output is clipped underscore. Okay, so it's sort of a prefix. Okay, so let's say the name of the file is uh, places. So all the layers that will get generated will be clipped underscore places, clipped underscore rivers, or clipped underscore roads, and so on. So this is the prefix that I'm going to add. I will be saving it like a geo package layer. You can also save it as a shape file, or uh, KML, or GeoJSON, and so on. So first thing we need to do is type clipped underscore here, and need to write select geo package in the save as type, and then click on save. As soon as I clicked on save, a new pop-up option box came which says autofill settings. The first drop down is autofill mode. Do you want to take this value and fill it down for all the boxes? Second option is you want to fill with certain numbers. I will going to take the third option which says fill with parameter values. Okay. So once I click on that, then it has again three options parameter to use. We are going to say input layer. Okay. So what it is going to do is from this input layer, let's say lakes, it is going to say clips underscore lakes and save it as a new file. Then clips underscore places and save it as a file, and so on. So now I'm going to say OK, and you see it says in the desktop, it will create in the batch processing and modeler folder clipped underscore places dot geo package, clipped underscore rivers dot geo package, underscore roads dot geo package, and urban areas dot geo package. Somehow it has not taken the lakes. Let me also uh, write clipped underscore lakes. Okay. Maybe this version has a small bug. I am going to manually fix the output files. Okay. So the lakes layer is going to be clipped and saved as clipped lakes. Places is going to be clipped and saved as clipped places, clipped rivers, clipped roads, and clipped urban areas. Okay. So just be careful what is the input, what is the output, and what is the output file name. Because once you run the model, after you click on the run button, there is no stopping the process. It will iteratively go through all the files listed here and clip them all together. So if something goes wrong, you have to repeat the whole process again, delete the existing files, and so on. So it is sort of a process. Okay. So now let me also say load layers on completion. So once the whole process is complete, all these output files will get added to my QGIS display. So now I'm going to click on run, and you will see it is automatically clipping 5 layers. You see, it says processing algorithm 1 of 5. It clipped, then 2 of 5, 3 of 5, and so on. And it created all these 5 files. Let's open our folder, and you see there are 5 clipped underscore files which have been created uh, in the output folder. Now we can close this batch processing box, and we can have a look at the I'm going to just hide all the other layers, and I'm just going to show my clipped urban, clipped roads, clipped rivers, and clipped places, and clipped lakes. Okay. So you see the data has now been clipped for the Karnataka state boundary. Similarly, you can run several of the tools in a batch mode. So this was just a very small example. Now, what you can do is all these files are in geographic coordinate system. Okay. Several times you need to convert the data or reproject the data into a UTM or projected coordinate system. So let's take UTM for example. Okay. So uh, maybe you can try as an exercise, you can pause the video here and try to run the correct tool to reproject all these files, the new 5 clipped files, into the UTM, let's say 44 north projection system. Okay. So you what the task is to reproject the 5 uh, clipped files to UTM 44 north. You can pause the video here and then play again. I am going to show the solution when you unpause. Okay, so maybe you tried doing reprojecting the vector layers. So the first thing is we need to find which tool does it. Okay, so simply let's try to see if I type reproject here, whether we get any options. So I can, when I type reproj in my processing toolbox filter, I see that under vector general there is a uh, tool called reproject layer. So let us try doing it for one layer. If it works, then we can try for all the 5 layers. So double click on it. And then I say, okay, for my clipped urban areas, my target CRS means coordinate reference system. My target reference system is, I want 44 north. So I'll click on this globe icon here. And then I am going to search for, let's say, UTM 44 north. So you will see that this specific row WGS84/UTM44 north, which has this code 32644. Maybe you can write it down, and you can, instead of searching for UTM44 north, just type 32644. This is a code specific to the 44 north um, UTM zone. So just click on it and scroll down. Oh no, just click on this back button and then scroll down and save it like a temporary layer. We're just doing a small exercise. So then I click on run and you will see it says algorithm reproject finished. Just click on close and it has created a new file called reprojected. Let me turn off the rest of the layers. So it is same as the, if you look at these polygons, it is same as the original clipped layer, but the difference is the earlier one was in EPSG 4326, which is geographic coordinate system, and this layer reprojected is now in uh, EPHD 32644, which is UTM 44 north. You can also have a look at the properties under so information. You will see the same information given here, that the name of the coordinate reference system is EPSG 32644, which is UTM 44 north. Originally it was um, originally the coordinate reference system was geographic lat long. Okay, so like this, our objective is to convert all the layers to its corresponding UTM 44 north. Okay, so how do we do that? We have to run this reproject layer tool in the batch mode. Right click, go to execute as batch process. Any tool that you want to run in the processing toolbox in the batch mode, you right click, execute as batch process, and then you fill the options. So the input will be auto-filled from the existing layers. So autofill from open layers. You see urban areas is already added. So take lakes, places, rivers, roads. Yeah, that's it. Click OK. Then what is the target CRS? This is the most important thing. The target CRS is, let's say, EPSG 32644. Just select that for the first one and say autofill fill down. So it will just take that value and copy it to all the layers below it. And then what is the output file? So you click on uh, the browse button and say reprojected underscore. Okay, and then click on save, and then you can give autofill mode as fill with parameter values. Parameter is input layer, and now click on OK. Wow, so we have reprojected underscore clipped underscore urban areas, reprojected underscore clipped underscore lakes, places, rivers, and roads. Now it has autofilled properly for all the 5 things. Now let's add load on completion and click on run. Voila, in a few seconds you have all your 5 files reprojected. Now let me click on close. First let us have a look at whether the files have been created. Yes, 5 new files have been created with the names that we gave: reprojected underscore clipped underscore the name of the feature. And if you look at the display, the layers are displaying correctly, and the properties also show that now it has the coordinate reference system has been set to UTM 44 north. Okay, now we go to the next part of the session, which is on modular. So I'm going to remove all these layers. Just click on a new project, click on project and new, and you don't have to save the changes. You can click on discard and all the files will be removed. Now our process is to use the modeler in QGIS. Normally, GIS workflows typically involve many steps, with each step generating intermediate outputs that is used in the next step. If you change the input data or tweak a parameter, you will need to run through the entire process again manually. Fortunately, Processing Framework provides a modeler or model designer that can help you define your workflow and run it in a single invocation. You can also run these workflows as a batch over a large number of inputs. So a model that we are going to design can also be run in the batch mode. So let us not confuse batch processing and modeler. Let us have a look at how we make a model, and then things will become more clear. So in the current example that I'm going to show you, using the data given, the data for the modeler is in this folder called modeler data. So let me just extract it in a separate folder. First step is to extract the data. Okay. Try not adding the zip file directly. Sometimes the modeler gives errors if you're trying to access a file which is inside a zip file. Okay. QGIS does allow you adding data which is zipped already. And if you drop the zip file, it will unzip it and show the files inside it. But modeler sometimes gives errors while doing that. So best thing is unzip the data. So I have the data unzipped in the folder modeler data. Here you will see two main files. One is a uh, stream network. We are calling it reverse.shp. It's a shape file. And we are going to use the SRTM dem uh, over the Dehradun, near Dehradun city. So the objective is, now I have uh, the river network, I have the dam. I want to find out the elevations near the streams, okay, and with varying buffers, with varying buffer distances. So it is usually a 2-3 step problem. First, you add the vector data, you create the buffer. It could be 100 meters, 200 meters, 500 meters, kilometer, few kilometers, and so on. So you have to vary these distances. And then with the buffer, which is sort of a polygon, you have to clip the raster layer, which is the DEM layer. Okay. So you see there are 2-3 steps involved. What if we could uh, put all these steps in a modeler and then on a single click run the whole process and get the final output? Okay, so that is what we are going to explore in this. There are three main steps. One is clipping the stream network for the raster extent. Now, this is a very interesting step that I added. My stream network is pretty large. Okay, it is not only for the uh, Dehradun zone or for the extent of my raster, it is beyond that. And if I have a larger stream network, it takes time to create the buffers and everything takes a little bit more time. So first thing I'm going to do is I am going to find out the or I'm going to clip the river or stream network for the extent of my raster. Okay, so I will have a smaller stream network, not the original big file. In the second step, I am going to generate a buffer along the clipped stream network. So whatever stream network that I clipped for my study extent or raster extent, for that I'm going to create my buffer and then use. Third step is clip the raster for the generated buffer polygon. And then we will see how we can run the model multiple times by adjusting the buffer distance. Okay, so for this we are going to use two layers. As I told you, let me add them. First one is the SRTM dem. So just click and drag this file uh, by the name N30E078.HGT, which is basically the DEM. So somewhere here is the Dehradun city, and then you have the Tehri Reservoir here and higher elevations in this single raster image. And the second one we are going to use is this raster.shp file. So I'm going to drag and drop this also in QGIS. So you see, it's a river network. Uh, Let me just change the styling a bit. I am going to show it in blue, but slightly thicker. So you see, it's a river network, but it is for a larger area. I don't want all this because every step has a time linked to it. So we will have to create buffers for all the networks, for all the streams, and then again do the clip process for all the streams. So uh, there is time. So the best thing is to first thing is to clip it for this extent and then go forward. Okay. So for this, we are going to use tools for this entire exercise. Two of them are native to QGIS, and one is from this provider called JIDAL. Okay. So the first one we are going to use is a tool called uh, extract by extent, extract or clip by extent. So there is a tool under vector overlay which is called extract or clip by extent. What this basically does is it takes the river network and it takes the extent of my DEM and it will extract it and it will create a new layer. So it will create a vector layer for the uh, given uh, extent of the DEM. That is step one. Step two would be to create a buffer. So we are going to use the buffer tool, which is under vector geometry. You see both of the tools are native to QGIS. That is why this QGIS icon is coming. This buffer takes the river network, the clipped river network, and it will take a distance. So here we will specify the distance in map units, which is degrees, and then it will create the buffer, which will be a polygon. So it will take a line as input and it will generate a polygon as output. Now using that polygon, we are going to clip our raster. So we have a JIDAL tool called clip raster by mask layer. So the mask layer is going to be the polygon we generated um, from the river stream by buffering the river stream. So we are going to take that as input. So the input layer will be our DEM and the mask layer will be the polygon that we generate. And when we run this, hopefully we should see an output which looks like the DEM has been clipped only along the streams. Okay. So you could apply this on any file that you have. Let's say you have land use and you want to find out what is the land use in the buffer regions of these streams. Okay. So how do we create that file? So you need a land use layer and you need a stream layer and the same process will apply. Okay. So let's go and see how the modeler is made. So first thing that you need to do is you need to create a modeler or model. For that, again, you need to use the processing toolbox. Uh, in the processing toolbox, the first icon on the top left, uh, where you see this mouse is currently, uh, it has certain gears in red and gray color. If you take your mouse over it, it says models. Click on that and you take the first option which says create new model. Okay. As soon as you click on it, a new pop-up will come up. So I'm going to expand this and we're going to focus on this uh, new box for this entire exercise. First thing that we need to do is resize these boxes. We need this inputs box on the left, mostly. In the first step is to give the name to a model. So the name of the model, you could give anything. I am calling it raster clipper. So whatever name that you give will appear in your toolbox also. Okay. You may give this group, you may not give this group. It is optional. I am keeping it blank. Second thing is, let us save it. So in case QGIS decides to hang on us, we can at least have what was done till now. So we are going to click on this floppy icon which says save model, and then at the default location, okay, save the file at the default location in this case, because if you save it somewhere else, the next time you start QGIS, you have to manually add that model. If you save at the default location, the next time you start QGIS, you will see the model in your toolbox already there. You don't have to load the model. It will already appear in your QGIS toolbox. But if you save it somewhere else, you have to load that model again. So we are going to save at the default place, processing models, and I'm going to keep the same name. It will be saved as a .model3 file. Okay, the extension of this file will be .model3. Uh, need not worry about the extension right now. So now it is saved. If you just minimize and you click on processing toolbox, uh, this option here which says models, you will see that your model is already appearing here. Currently it is an empty model, but it is appearing there. Okay, so first thing is we need to add the inputs. So this panel here on the left, the topmost panel which says inputs currently, has two tabs. If you look carefully, there are two tabs. One says inputs, the other says algorithms. Okay, so inputs and algorithms, this is where we will spend our most of our time for this exercise. So first we will add the inputs. There are three inputs that we will use. First is the DEM layer, which is a raster layer. Second is the stream network, which is a vector layer. And third is the buffer distance, which will be a numeric value. It's a scalar value. Okay, so let me first add these three inputs and then we will see the algorithms that we are going to add. So first is DEM, which is a raster layer. So if you scroll, this is in alphabetical order. So if you scroll down, you should see an option which says raster layer. Just click and drag it to this empty space here. As soon as you leave your mouse, a box will come up. It will ask you the description. Let's say the description I want to add is DEM. Okay, so whatever you write here will pop up when you start the tool. It will first ask you for a raster layer and ask you to select a DEM. Or let's say I give a more descriptive description, select the DEM layer. Okay, so select the DEM layer. Now click on OK. Here you have to just specify that this is a mandatory input, otherwise, or just keep the default settings and click on OK. So you see then you've now added your first input to the model. The next input is the stream network, which is a vector layer. So again, on the left side input panel, you will see a vector layer as listed here. Just drag and drop here. Again, give a description. Let's say select the stream network layer. Okay. The next is the geometry type. Here we can specify that it is a line layer, right? So the river network or stream network is a line layer. And just click on OK. Now I have my second input, which is a vector input. The third input, as I told you, is the buffer distance, which is a number. So there will be a option called number here. Okay, this may appear as a different name in your version. You have a different version of QGIS. You may see numeric written here, or maybe some other word. So in my version, it says number. Just drag and drop here, and then it asks you what is the description. I'm going to say the buffer distance and within bracket, just to remind that this is in map units. So currently all my layers are in geographic lat long in degrees. So whatever I give will be in degrees. Whatever distance I'll give is in degrees. So what is the number type? Whether it is integer or float, I want to give a decimal number. So I'll keep it float. You can specify a min-max range. What I'm going to do is I'm going to say the default value is 0.01 and then keep it as mandatory. Okay. Then I'm going to click on OK. So now I have my 3 inputs to the model is ready. Now, what is the model going to do? First thing it is going to do is it is going to reduce the size of the river network. The vector is very large. I want to clip it to the raster's extent. So I need an algorithm. So I'll go to the left side. Now I'm going to click on this algorithms tab. Okay. And then I am going to search for a tool called extract slash clip by extent. Okay, so there is a filter box here. You can type extract slash clip, and this option should come. There is no spaces between extract and forward slash and clip. If you add a space, maybe uh, it will come, it may not come in certain versions, or just type extract clip. That will also do matching and it will. So we need this first tool under vector overlay called extract clip. So I'm going to drag it and I'm going to drop it here between my raster and vector. Okay. Just going to expand this box to show you all the options. What am I going to do? I am going to take my stream network, which is a model input. Okay. So first thing is this icon here, which say under input layer. Click on that and select model input. Okay. It has to be model input. What is the input? Uh, the the DEM layer or the stream network layer. So select the stream network layer is my model input. And what is the extent that you want to clip it for? Now there are many ways you could do it. You could just manually type the extent, okay, which could be like a value that you give. Or I want to calculate it from the raster layer. So that is the pre-calculated value, the second option in this drop down. So under extent, you will see an icon which says 1, 2, 3. Just click on that and select the second option which says pre-calculated value. Then you click on this icon which looks like a epsilon or a summation sign. Click on that and you will get a new box called the expression dialog box. So here what I'm going to say is I'm going to say extract a layer property, a layer underscore property. Okay. So there is an option, a function called layer underscore property, which returns some kind of a metadata or some kind of a property from a layer. It could be the name of the layer, it could be ID, title, scale, and so on. What I want is the extent, the layer extent as a geometric object. So I want the layer property. What is the arguments that you have to give to this function? First is the layer name, second is the property. So let me double click on this layer property and then I need to give the layer name. What is the name of the layer? The name of the layer is select the dem layer is the name. Okay. So this is my dem. So I'm going to double click on this, followed by I'm going to type with my keyboard comma, and here you'll see it is asking for property. So the property is extent. So within single quotes, I am going to type extent. Within single quotes, you type your extent and then close the bracket. Okay. So that's all you have to type. You could do the whole thing manually, but it's best you select from this options in the middle. Layer underscore property within bracket at the rate the name of the layer. So if you had given only dem, so at the rate dem. Since I had given a more descriptive name, select the dem layer. It is showing the whole name. At the rate dem layer, comma, within single quote extent. Again, Here, please do not write double quotes. Double quotes have a different meaning here. Single quotes have a different meaning. So in this case, it has to be single quotes. Now click on OK. So here, uh, and the third thing I will give is clip features to extent. I will, I, the difference between no and yes is, let's say there is a stream which is starting inside your raster and going beyond that. So you want to keep the whole stream or you want to clip it for your raster extent. So I want to clip it for my raster extent. So I'm giving it yes here. So what I have changed, I have first input layer is my model input. Extent it is calculating from my raster. And I am clipping it yes for my extent. And this is the output extracted. If you, so it says here in gray color, enter name if this is the final result. If this result you want to save as the output of this algorithm, you write certain. If this is an intermediate output, which you are going to use in your next step, then you do not have to save this. So don't write anything here. Okay. Now I will keep this as blank and click on OK. So now you see it has automatically drawn these lines. It takes input from stream network. It calculates the extent from the DEM and it clips it for that extent. The next step is for this clipped stream network, I want to calculate the buffer. So what I need is the buffer tool. In the algorithms panel, I am going to type buffer in the filter box here, and I'm going to select the first option under vector geometry called buffer, drag and drop this box here below stream network and buffer distance. So here we have to specify some more options. Uh, First is what is the input to this tool, whether it is this stream network here or whether it is the output from this extracted. So this is the output that we are going to use. It is not a model input. The input to this function buffer is not an input to the model. It is an output from a process. So what I'm going to say, it is an algorithm output, not a model input. So in this input layer, in this gray, in this gear option, you click on it and select the second or last value, which is algorithm output, and automatically it will populate. Do you refer to extracted from algorithm extract clip by extent? So the output from this algorithm extract clip by extent is called extracted. That is what we are going to use. Now, what is the buffer distance that you want to apply? Do you want to give a single value or you want to take it from the user? Now, this is a user defined input. It's a model input. So under distance, I'm going to click on this icon 1, 2, 3 and change it to model input. And it will automatically select this option buffer distance. A few more options I'm going to change. I am going to change dissolve results to yes. The rest of them you can keep it a default segments and meter limit and all that. But yes, dissolve the results. So this is yes. And the last option, that is dependencies. This is important. Now, how modeler works is if you have multiple algorithms in your model design, it will try to run, or just to optimize time, it will try to run them in parallel. Now, in this case, the model is very serial in nature. It has to first do the clipping, then find the buffer, then find the clip of the DEM. So none of the steps can be skipped in middle. So one step is dependent on the previous steps, right? So the previous steps must be completed before the next step can start. So to specify that, under buffer and the last option which says dependencies, click on this browse button here and click on this option extract clip by, because that is the only uh, dependent process before this. So that must be completed before I can proceed. So after I click OK, you will see one dependency selected written here. What this basically means is before I run this buffer, the extract process should get completed. Now click on OK. You see it will draw three lines. One, the output from this extract clip is an input to buffer. The buffer distance is an input to buffer. But it is also dependent. So that is why this third line. It is dependent that this process should get completed, then this process will start. Okay, great. So technically we now have our buffer for our stream network generated. Next step, what I want to do is using this polygon, I want to clip out my original DEM layer. So this layer will need to be clipped out. So what I'm going to do is, just for sake of uh, understanding, I'm going to place my boxes like this. Okay. The next step is clip. Clip raster by mask layer. So this is the GIDAL tool. This is not native to QGIS, but a lot of GIDAL tools are used inside. In fact, all the raster and vector reading and writing is done through GIDAL. So we are going to use a GIDAL tool called clip raster by mask layer. So I'm going to drag and drop it here. And what are the inputs to this? The inputs are my algorithm outputs. The first input layer is the DEM layer. So the input layer is a model input, which is the select the DEM layer. Second is the mask layer. This is an algorithm output buffered from the algorithm buffer that is written here. Some of the options you may specify. Uh, I just found that keeping this makes it better. So keep resolution of input raster. So whatever is the input raster resolution, 30 meter, 90 meter, the same should be written in output. So this I will make it as yes. So keep resolution of input raster is made yes. And last two things that I need to change is uh, this is my final output. This is the output that I want to save. So I want to say I will type here in place of clipped bracket mask, which is the final output. You see this green arrow, type clipped result. Okay. So this is the final output. And the last option is these dependencies. Again, this algorithm is dependent on completion of the previous two algorithm. So you click on this browse button here and say select all. Make sure both these processes before me are completed, or in fact, the buffer should be completed. Now buffer will be completed when this fellow will get completed. Okay. So when the buffer is completed, then you fire this event and then you give me the output. So as soon as you click on that, you will see that uh, a new box has come, clip raster by mask layer, and it is automatically generating an output called clipped result. So this is the final model that you need to design. I have just clicked on save, and now the moment of reckoning, let's run this model. So how to run this model? If you close this model designer, you can just go to models and double click on this raster clipper. Or if you want, you can run it in a batch mode. Many things you could do. If you want to edit it further, you right click on it and say edit model. You will get the model back and you can run the model from this green button here also. Okay, so let's run the model. Now we have created the model, let's run it. So you see it's first asking the buffer distance, then the DEM layer, then the stream network. I don't like this order. I want first it should ask the DEM layer, then the stream network, then the buffer, and then the result. So you can change the order of the model inputs. How? Go back to editing this model. Under inputs on the left panel, you will see an button called reorder model inputs. Just click on that and take this buffer distance and push it down. So now first is select DEM layer, next stream network, and last buffer distance. Now click on OK. Save, close the model, and go to models and run it. First, the DEM layer. So it will automatically, if you click on the drop down, it says I find a raster. Next, I have to give a line river. So it is saying that, oh, I found a river network. So it has automatically selected that. Then the buffer distance. So first, let us keep it at 0.01 and let's save it like a temporary file and then click on run. So now it is doing 2, 3 steps one after the other. Okay. So what it has done, it has done uh, clipping the river for the extent. Then it has generated a buffer, and then it has clipped the raster for your buffered. Now click on this box. You don't see any change, but when you turn off the two layers, rivers and your DEM, this is the final output, the clipped result. You see what it has done? It has basically generated a buffer around the stream network and then clipped your DEM or any raster input that you give for that buffer distance. So this is the uh, uh, utility of modeler. You can combine multiple steps and it will be just like a tool in your toolbox. You can give several inputs, apply several types of algorithms on all these inputs and generate a final result. uh, so that is what I wanted to show in this session. What you could try doing is running this model for different buffer distances and see what different outputs you get. And also maybe you could try editing the model and mm, try saving the result in a different projection system. So whatever is the output here, don't save it. Instead, take this as an input to another tool. Let's say uh, Project Rust. There is a tool called uh, hmm, Warp. There's a tool called Warp under JIDAL. This will help you reproject a raster, the final raster, into a different projection system. So currently it is in geographic lat long, which cannot be used directly into your, let's say you want to find slope and all that derivatives. You need to convert it to a projected coordinate system. So can you add this here and generate a new output? So that is an exercise for you. That is all from my side. Thank you.